Hello everyone. This is Dr. Jyoti Saxena and today I'm going to discuss the 2-log virus removal. I have also prepared and uploaded a video on the log system as such, as a whole, but this one is basically focused on the 2-log virus removal. Before going into the details of 2-log system, let's see what is the log scale. The log removal system is how scientists and engineers describe microbial safety in wastewater treatment. This is something which is universally accepted scale. The log system measures how efficiently the viruses or other microorganisms are removed or inactivated in a treatment process. Actually, this log scale theoretically includes all type of microbes, microbial removal, but practically this is used for the viruses in wastewater treatment. It is expressed in logarithmic scale to represent large reductions easily. Log system compresses very large removal factors into easy numbers, and it can be 1 log to 6 logs and even up to 12 log is possible. Even higher is also there. Higher logs are also there. If we say 1 log, which is the lowest level, so 1 log means 90% removal. That means in any sample, 90% of viruses have been removed. If we say 2 log, then in percentage it is 99% removal, and 3 log is 99.9% removal, and so on. If we say 6 log, then it is 99.9999% removal. So, that is, almost no virus is there. Okay, now let's see how 2-log removal is achieved. A single method may or may not be reliable to achieve the 2-log for all the viruses. So, it's more suitable if you use more than one method. So, 2 methods or even more methods are applied for the virus removal. The first one is coagulation plus flocculation plus sedimentation. So, these are 3 processes which are used to achieve the 2-log removal, one after the other. In the coagulation, what you do, first some chemicals are added or the coagulants are added like alum or ferric salts. So, these are why these are added? To neutralize the particle charges, and that causes the clumping. And then in the process of flocculation, the viruses, they attach to the flocs and the flocs are formed. And then in the sedimentation, these heavy flocs, they settle down to the bottom, and viruses also settle down with along with the flocs to the bottom. Then effectiveness of this method depends on the pH, what is the pH, mixing, coagulant dose. So, all that factors are there. It can be achieved around 0.5 to 2 log removal when it is optimized. Then the second one is filtration. Sand, dual media, rapid filters, any of these filters can be used. Or all of them can be used one by one. When you use single sand filter, which is a single layered filter, then dual media, that means 2 layers are there, top layer and then the bottom layer of sand. And rapid filters have very fine sand particles. So, this is better, the best one actually. Now, filters, physically strain the virus attached particles and they remove the suspended solids. So, that's how the viruses are removed. But still, some of the free viruses are also there in the sample. So, removal of these small particles also improves when they absorb to the particles first. If they are free, they are very small, so it becomes difficult to remove them. But if they are absorbed to the particles first, then it becomes easier. Then proper backwashing just to clean it, and filter maintenance. These are essential here if you have to do the filtration. And typically it can contribute to 1 to 2 log removal efficiency. So the efficiency is 1 to 2 log. Then the third one is membrane filtration. Here you use membranes. MF is microfilter, then UF is ultra filtration, nano filtration, and RO is reverse osmosis. So all these different membranes are according to their pore size, and their efficiency is also according to their pore size. These membranes, they act as physical barriers, and as I said, that the pore size determines the viral removal. Ultrafiltration and tighter membranes block most of the virus directly, because ultrafiltration and nanofiltration RO, these are better, so they can block most of the viruses. Achievable virus removal is 2 to 6 log. So not only for the 2 log system this membrane filtration is used, but even if you want to achieve the higher log levels, then also this membrane filtration can be used. Okay, so the next one is chlorination, which is a very common method for the virus removal. Here we add chlorine, and chlorine oxidizes and damages viral proteins and nucleic acids. So that's how the viruses are killed. The effectiveness of this method depends on the CT value, that is the concentration, and what is the contact time. So that is important here, and also on the pH. But this chlorination method is not for the resistant viruses. Like adenovirus is called as the resistant virus, so it may not be killed by the chlorination, and typically it gives 1 to 3 log viral inactivation in clean water. So chlorination is generally done for the water which is used for the drinking purposes, and also for the swimming. Swimming pools are generally chlorinated. Next one is UV light, or here we use the UV radiation, and the wavelength is 254, to be precise, it is 253.7 nanometer. When the UV radiation is given to clean the water, it damages the DNA or RNA, whatever is present in the viruses. So that's how it prevents the replication. Clear water and proper UV dose are critical for best performance of the UV light. It is quite fast, this method. Also chemical free, because here we are not using any chemical, and widely used as a final polishing step. That means the and step. At the and, towards the and, this is used. 2 to 4 log virus inactivation can be achieved when it is properly designed. So not only for the 2 log system it is used, but even for the higher ones, up to 4 logs, it can be used. Next one is ozonation. Of course, here the ozone is used, and ozone is a very powerful oxidant, and it reacts very rapidly with the viral envelope. So it can kill all the viruses which are enveloped, and genomes also. So it can penetrate the cell wall and inactivate even the resistant viruses. So it is good for killing the resistant virus as well. It needs controlled contact time, should be there in contact for some time, and residual monitoring is also very important here. And it provides 2 to 5 log viral removal. So that means it is used in many of the log levels. Next one is advanced oxidation processes. These advanced oxidation processes used are UV, ultraviolet, and H2O2, hydrogen peroxide, or the ozone plus H2O2, that can also be used, and they generate the hydroxyl radicals. And these hydroxyl radicals are extremely reactive. So they are very reactive, These radicals attack the viral protein coat and also the genetic material simultaneously. And this is useful for resistant as well as for non-enveloped viruses. Even if they are the naked viruses, then also it is useful. And it can contribute to 2 to 6 log removal depending upon the design and exposure. So this is advanced method actually, which can be used for the higher log also. We generally use the combined approach. Not just one method is used, but the multiple treatment processes are used to reach the 2 log. Because initially I said that one method may not be sufficient to kill all kind of viruses. So it is better that we use multiple treatment processes. Primary, secondary treatment is given first, and then after that coagulation, flocculation, sedimentation, these are done. And then after the filtration is done, and then at the end the disinfection is done, which can be done by the radiation or by chlorination. And here each step contributes part of the removal. So, because all these are the processes which are for the virus removal. So if you use the first process, then also some of the viruses are reduced. Then when you use the second process, then again some of the viruses are reduced. So that's how at the end result is 2 log. So if you require the 2 log, you want to achieve 2 log, then at the end the cumulative result should be 2 log. The real examples and industrial uses, in cooling towers, it can be used. These are used in many industries where the extra energy or extra heat is, expelled into the atmosphere. So there it can be used. And irrigation of non-food crops, because these crops are not used for the human consumption. And also for the landscape irrigation of the trees and flowers and all that. And also it can be used in construction sites when the long towers and buildings, multi-storied buildings are formed, then lots of water is used there. So site water can be this one. And for controlling the dust also, the reuse of this water is possible. And certain industrial processes can use this water, like cooling, if you have to wash the equipments in boilers. So then also this can be used. Now, where the 2 log standards applied. So this is also the table which is showing the same thing. The treated sewage reuse, the application is in landscaping and irrigation. 2 log is minimum here. So the required log value is 2 log. And this is acceptable because the risk level is not much here. It is used only for the outdoors and less direct exposure is there. So it can be used. Then the next one is toilet flushing or the gardening at household scale models, at a small scale models. So here mostly 2 log system is used, but it is combined with 3 log. And why the risk level here? Because here the risk level is again very less, because it is a small system, and moreover it is also combined with 3 log, which is a higher value. Then if you see the industrial reuse, cooling towers needs lots of water. So there you can use it. In textile industry, in paper industry also you can use it. And 2 log is sufficient for this purpose. And here also there is no human consumption. So there is no risk. Then surface water protection, like in general river discharge or recreational lakes, if you are using this water which has been treated, and that should be 2 to 4 log. And for recreational lakes, it should be 3 log because many times in recreational lakes the water may come in contact with the human body. Then washing in labs can also be done with the 2-log water, and after this the chemical disinfection is also done. And for the construction purposes also, this 2-log is sufficient in cement plants while the road work is going on, for the dust suppression. So these are some of the applications where the 2-log is sufficient, and because it is not coming in contact with the food or drinking water, so that is okay. So there is not much risk. Now let's see the risks and limitations of using only 2-log. Residual risk always exists because here the 99% removal is there. In percentage, if you see, in 2-log, only the 99% viruses are removed. So still 1% viruses are left. And if the concentration was very low, then 1% is still okay. But the concentration is very high. In those cases, the number of the viruses which are left in the sample may be quite significant. And the virus diversity is also, something, because some enteric viruses are more resistant to chlorination, and even they do not die after the UV radiation. So that kind of risk is also there if you are using only 2-log. And water quality dependency, what kind of water you are taking for purification, like poor turbidity or high organic load, that reduces the disinfection efficiency. How? Because it shields the viruses. Viruses are present there in the sample, and because of this high organic load, it shields the viruses from the UV radiation. When you give the UV radiation, many of the viruses may not die and may consume the disinfectant. So that's how this is the limitation. And of course, this 2-log water is not suitable for the potable use. You should not use it for the drinking purposes. And this can't be used alone. It should be the part of a validated multi-barrier strategy. Like for drinking purposes, we are using the 4-log. So it can be a part of one step. But after that, many more methods should also be used to reach to 4-log. Now, how we should conclude it, or what are the key takeaways? 2-log is 99% removal, which can also be called as 100x or 100-fold reduction. And of course, it is good for many non-potable uses, but when it comes to drinking purposes or when the water is coming in contact with the human beings, then it may not be used. And this is best achieved as part of a multi-barrier approach. Many methods are applied, and there you can use 2-log, 3-log, 4-log, whatever, to achieve the higher log. And at last, the validation is required. At last, you have to see whether the 2-log which you wanted to achieve has been achieved or not. And for that, the monitoring is used. And also the surrogates are used. The viral surrogates are like bacteriophages. So because, to test all the human viruses, it becomes very impractical. So some of the viruses can be used, for example, the bacteriophages. So that is all for today. Please keep watching my videos and subscribe the channel. Thank you.